Welcome to chapter 6. So in this chapter we'll talk about exponential and logarithmic functions. So let's start with the first topic, exponential functions. So after you complete this section, you should be able to evaluate exponential functions, find the equation of an exponential function, use compound interest formulas, evaluate the exponential functions with base e. So let's start with the first topic, how to identify an exponential function. So an exponential function for any real number x, an exponential function is of the form f of x equal to a b power x. So if any function is of this form, so that function is an exponential function. Remember that this is not the same as that of a polynomial function. In a polynomial function we have the variable and the power is constant. But here the value is a very constant and the power here is a variable. So here a is a non-zero, non-real number called the initial value, and b here is any positive number, and so we should always remember that p should not be equal to 1. And the next one is that the domain of f is all of the real numbers and the range of f is all positive real numbers. So only if a is greater than 0, and the domain of f, the range of f is all negative numbers if a is less than 0. So the a value plays a critical role in determining the range of an exponential function. Now the y-intercept is 0, a, and the horizontal asymptote is y equal to 0. So remember that there is no vertical asymptotes yet, but we do use horizontal asymptotes. So the horizontal asymptote is the line that basically grazes along the curve. So this is an example of the curve of f of x equal to 2 power x. So this is the idea. So this is an example of an exponential function f of x equal to 2 power x. So notice the curve here. Every exponential function will always pass through this point 0, 1, provided that it does not have any constant added to the function. So the nature of a general function of an exponential function will always pass through the point 0, 1. Now, so let's determine which of these functions are exponential and which of these are not. So first things first, let's take a look at each of these functions. First one, you have f of x equal to 2x square minus 3x plus 1. So the first thing we need to remember is that it should be of the form a b power x, and there should be a and b are constants and x is the variable. So no function here has the way that this is here. So all of these are not exponential functions. Next, let's talk about this function here, f of x equal to minus 4 power 2x plus 3, and they're asking us to evaluate f of minus 1. So how would you calculate? So given f of x is minus 4 to the power 2x plus 3, and we are finding f of negative 1, so it becomes minus 4 power 2 times negative 1 plus 3, so that becomes minus 4 into power minus 2 plus 3, so minus 4 power 1, so it becomes minus 4. So f of negative 1 is minus 4. So this is how you can evaluate an exponential function. So use the same principle now. Pause the video right here and try to solve this problem. Next, let's talk about exponential growth. So exponential growth is a function that models the exponential growth, is basically where the growth is increasing by a rate proportional to the amount that is present originally. So for any real number x and any positive real numbers a, so that the exponential growth function is given by f of x equal to a b power x, where a here is called as the initial or starting value of the function, and b here is called as the growth factor. So remember this point, that this is called as the growth factor per unit x. Next, so let's start with this problem here. So at the beginning of this section we learned about the population of India was about 1.25 billion, so with an annual growth rate of 1.2%. So the situation is presented using this function here. So this is the function that explains that particular population growth rate. So p of t is equal to 1.25 times 1.012 whole to the power t. So where t here represents the number of years since 2013. So to the nearest 1000, what will the population be in 2038? So notice that we have to find t. So t here is 2038 minus 2013. So which is about 25. So we are finding for 25 years. So P of 25 becomes 1.25 times 1.012 to the power 25. So you can just use a calculator and calculate the exact value. So 1.012 to the power 25, so becomes 1.3474 times 1.25. So multiplying it with 1.25 gives you a value of 1.6843, and here this is the population here of P of 25 years, so this is the billion value. Next, let's talk about finding the equations of exponential functions. So given two data points, we have to write an exponential model. So how to do this? First, if one of the data points has the form 0, a, so then that a value here represents the initial value. And using a, you can substitute the second point into the equation f of x equal to ab power x, and we can solve for the value b. And if neither of the data points have the form 0, a, we substitute both the values into the equation and find the resulting unknowns by solving those two equations. So remember that we have to find a and b anyway to find the exponential equation or exponential function. So let's start with this point here. So a car is sold for $26,000. After 1 year, the value of the car is $16,900. Write an exponential function y to determine the value of the car after x years if the rate of decrease is the same each year. So let's start with the value that is given here. So f of 0 is given, so this is a 0th year. So the original value is $26,000, and at f of 1 the value is $16,900. Notice that this point here represents the value 0, a. So here this value becomes a. Remember that if f of 0 is this value, that value itself becomes the value a. Next you have 1 here. For 1 it is 16,900. So first thing we need to do is write down the equation f of x equal to a b power x. So substitute this value into this equation. So you have f of 1 equals a, we already know, is 26,000 times b to the power x. So we want to find the x value. X value is already given 1. So b here becomes f of 1 is 26,000. So f of 1 is 16,900 divided by 26,000. So use the calculator and find the two values. So 16,900 divided by 26,000 becomes 0.65. So the b value here is 0.65. So finally we have both the values. We have a and we have the b value. So substitute both of them into the equation. So we know that equation is f of x equal to a b power x. So f of x becomes a here is $26,000 times 0.65 to the power x. So this is the answer for the given equations. So use the same principle now. So what is given in the problem? A wolf population is growing exponentially. In 2011, 129 wolves were counted. By 2013, the wolves population has reached 236. What 2 points can be used to derive an exponential equation modeling this situation, provided that we represent the population n over time t? So here you can consider that this value here is the initial value. So this is the a value, and this is where this value is. Notice that this difference here, we are starting at 2011 and this is 2013. So f of 2 is given, which is 236. So use the both values now and try to determine the answer for the problem. So next, how to apply the compound interest formula. So let's discuss the compound interest formula. So the compound interest formula is given as a of t equals p times 1 plus r by n times power nt. A of t here is the account value, t here is the time measured in years, and P here is the starting amount that you're putting it into the bank or any other or a loan. Often it's called as the principal amount, or more generally the present value. And R here is the annual percentage rate as a decimal, and N here represents the number of compounding periods in 1 year. So let's do a problem so that we can understand this better. So you have an initial investment of $100,000 at 12% interest is compounded weekly. So we are using 52 weeks in a year. What will be the investment worth in 30 years? So here write down all the data that is given. P here is $100,000. R here is the rate, which is 12%, which is 12 by 100, so which becomes 0.12. And it's compounded weekly, so when we are doing it for an entire year, there are 52 times that can be done. And we are finding for a total of 30 years. Now, substitute everything into the formula. So A of t equals P times 1 plus R by N power Nt. So P here is $100,000 times 1 plus R by N is 0.12 by 52 to the power 52 times 30. So let's first find 0.12 by 52. So that value becomes 0.100,000 times 1 plus 0.0023 to the power 52 times 30. So that to the power of 52 times 30. So 52 times 30 is 1560, and we are taking the value 1.0023 to the power 'So you have 52 times 30, which is 1560 to the power 1560. So that becomes 36.013. Times 100,000. So multiplied by 100,000 becomes 3,601,300. So this is the amount of value that you end up with when you compound with 12% interest with 52 times a week. So this is the amount you end up with. So this is how compounding in general works. So use the same principle now. Pause the video right here and try to solve this problem. Here they have given that 529 plan is a college student saving plan, and they have given that Lily wants to set up a 529 account for her new granddaughter, so to grow $30,000 over 18 years. So she believes that the account will earn 4% compounded semi-annually. Semi-annually is twice a year. So the principal amount is $30,000, and she is earning an interest rate of 0.04, which is 4%, and they are compounding it twice a year, and the total time for it is 18 years. So pause the video. So try to substitute the values into the problem and try to get your answer. Next, let's talk about the evaluating the functions with base e. So the base e here represents the value 1 plus 1 by n whole to the power. So the base e here is an irrational number. That irrational number value is e equal to 2.71828. So this is the closest constant value that we can find. And this generally works with the type of model called the exponential model. So e is also called as the natural exponential value, and this natural exponential value is what we generally use for many mathematical models, and it is really good to model data using these principles here, and it makes it easy to understand the problem as well. So they're asking us to calculate e to the power 5.2.53. So notice that e here is already embedded into your calculator, so you don't need to type the value for every single time. So if you look on your calculators, you can find the value e there. So let's start with talking about one model, which is also called the continuous growth or continuous decay model. So continuous growth or decay model generally starts with for all real numbers t and all positive numbers a and r. So continuous growth or decay is represented by the formula e of t equals a e to the power rt. So where a is an initial value, r here represents the continuous growth rate per unit time, and t here represents the elapsed time. Now, if r is greater than 0, we call it continuous growth, and if r is less than 0, the formula is called as the continuous decay. So the r value itself represents the actual rate and the continuous growth rate. So here if r is negative, it is decay rate. If r is positive, it is growth rate. So that is how we can differentiate between the two different types. So for business applications, the continuous growth formula is what we call the continuous compounding formula. So we write it as e of t equals p e to the power rt, where p is the principal and r is the growth rate or the interest rate per unit time, and t is the time period of investment. So let's start with how to investigate the continuous growth, and let's try a problem first. So what is given here? A person invests $100,000 at a nominal 12% interest per year, compounded continuously. What will be the value of the investment after in 30 years? So the principal value is $100,000 and the rate of interest is 12%, which is 0.12, and the time period is 30 years. So the formula for continuous growth model a of t is equal to p e to the power rt. So the principal is $100,000 times e to the power r is 0.12 times 30. So try to calculate using the calculator. Pause the video right here and try to find the answer. So you have 0.12 times 30, and if you take e to the power for that value, you should get a value of 36.598. So 36.5982 times 100,000. So which is about $3,659,823.44. So this is the amount after 30 years. So this is the amount after 30 years, and this is how you can find the data. So use the same principle now. Pause the video right here and try to solve this problem. Here they are talking about decay. Notice that decays at 17.3%. Notice that it's decay, so which means this value is negative, so 0.173, and it decays per day, and they are starting with 100 milligrams of radon 22 in 4 days. So this is the original amount. So this is the actual amount that you have. So notice that it is a e to the power rt. So small a here represents 100 milligrams. So they are asking you to find a of t, provided that t here is 4 days. So the rate of decay is given as per day. So using that value, we can easily find the data that we need. So use the same principle now, and they are asking you for rate and decay with after 1 year. So 1 year represents that this is 365 days. So you can use the same principle here, but time here is t is equal to 365 days, and try to solve the problem. So with that, we end our topic on exponential functions.